Alright guys, today we're going to be doing the standard normal curve. And with the standard normal curve, what we've done is we've taken all the values that you would normally get and we've standardized it through a process of coding. And the coding we use changes our x values into z values. So we use x minus the mean divided by the standard deviation, and we're changing it into new values of z. So for example, if you have some kind of curve, your normal curve with a mean of, let's say, from a classroom, 65% on average, students have got 65% on average. We now standardizing this to a curve that we could use for any set of data. So let's say you got another class here, and this class got 60% on average. We could standardize any curve, any set of data at any point in time to a normal curve such that the mean becomes 0. And so therefore we say mu will equal 0 and sigma will equal 1, or the variance will equal 1. So in other words, as we go further and further from 0, we will add and subtract 1 as our standard deviation. Alright, so we get our standard deviation, moving away from it. This is a standardized form that we can use at any point in time, and this was developed so that we could also create probabilities and percentages around a central table where over here we've got all the different percentages or area underneath the curve, and above you can see we have a picture of it as well. Alright. So that's what happened. That's basically, you got your normal curve, which normally is 65. Remember, you got 66, 67, 68, 69, up to 100%, remember, and 0 on this end, likewise. But now we're changing it into standardized normal curve. So we use some kind of coding, and we use this formula, z equals x minus mu over sigma, where sigma is your standard deviation and mu is your mean, your initial mean. Let's look at an example now of this. Suppose you're given a variable y, which is distributed normally with a mean of mu and a variance of sigma squared. And we are told that the probability of y being less than 10 is equal to 0.75. We're also told that the probability of y being greater than 12 is equal to 0.10. If I have to sketch the curve for each of these now, let's quickly sketch the first one. Remember, 0.75 is 75% of the data. And remember, my mean is mu. So this is, you would say, x, this line here. If I have to look at my x-axis, just to go back, just to reiterate, this is going to be an x-axis, and it's now changing. It's standardizing into a new axis called the z-axis. So these over here will be z values, and these over here would be x values. So we're changing our x values into z values using that formula. Okay, so if I have my original x values in place, then I'll have a mean of mu and a standard deviation of sigma. But at the same time, I also know that I want an area of 0.75 and it must be less than a number. So when it's less than a number, it's got to go left away from the number. And the area underneath that curve has to be 0.75 or 75% of the curve to the left of a number. And that number is 10. The only way that's going to happen is if it's on this side. Because half the curve to the left is already, that's 50%. And if this is another 25%, then we're good. And this total area becomes 75%. That's how we would draw it. Now we want to generalize this. We want to change this into 0. This is the x values. We want to change this into z values now. And we're going to call this one ZA. We want to calculate that using the z curve. And we would say ZA is equal to x. Yeah, so we're using the formula and we're going to go x minus mu over sigma. We know our x value. Our x value here is given. It's given here as 10. We don't know what the mean is, and we don't know what sigma is. All right. By the way, the question is actually asking us to find these two values. So the question, just to state the question, is find mu and sigma. So here we go, ZA. You can see Z from the Z tables is found by taking x minus mu and dividing it by the standard deviation of this normal curve. And from this, we can then do exactly the same thing. And you can see that this curve here is going to be having a mean of mu. This one here says greater than 12, you must have an area of 10%. So here the area is equal to 10% and it's greater than a number. The only way that's going to happen is if that number's over here. And this area over here would be 10%. We would then create exactly the same thing. Again, we want to generalize this or standardize this to the, standardize it to the Z values using x minus mu over sigma. And I'm going to call this ZB. So ZB is going to be x minus mu over sigma, basically 12 now we know, minus mu over sigma. Now, to find the Z values, we need percentages, and that's why we have the Z table. So we got the Z table, we've got all of these are percentages. And you'll notice it starts from 50% and it works its way all the way downwards. And it's basically talking about this particular graph. So if you go 50%, you're looking at 0, right? Which is going to be exactly there. And as you move away from 0, you go further and further into the curve from 50% onwards all the way till 100%. And as you go 50% to 100%, it works its way down the page up till there. So this entire region on the inside here is the area. It's the percentage underneath the area. And on the left hand side here, we've got our Z value. And our Z values we read off from here, as well as collectively from this side. Now, if I want to read off this particular Z value, the one thing I note is that it's 75%. So I've got to look for what is the Z value for 0.75. And we also want it to be less than 10. So it cannot reach 10. So let's go to 0.75. And if I go to 0.75, I can see it's going to be around here. And if I read off this value, I got 7, 0.7, 0.6, sorry, 0.6, 7. And if I'm going halfway between, I'm going to find the region that's, so what number would I add to get it as close and close to 0.75? I can add 14. If I add 14 to 86, I will get to 0.75. But if I add 13, it will be less than. So 13 is the way to go. So I got over here 0.674. And the 13 is added onto the last two decimals of my decimal. So it's going to be equal to 0.674. All right. If I look at this one, yeah, I got 10%. But the curve at the moment, you can see the curve only has the left-hand side shaded. So I need, if this is 10%, that means this side has to be 90%. So technically speaking, I won't find 10%. It starts at 0.5. It won't be big enough. So I need to use 90%. And if I use 90%, or I look for 90% on my Z table, that will give me the exact Z value that I need. So I go to 0.9. So 0.90 would be over here. And if I look at 0.90, it will be between there and there. So it's going to be 1.2, 1.2, and then 1.28, you can see. And suppose I add 2 onto this. This will become 0.8999. But if I add 4 onto 7, it will topple over. It will go over the 90% mark. And if I look at it carefully, it says greater than or equal to 12, which means it has to go further than 12 on my graph. Okay, so I'm going to go with 2 because that will ensure I get 90%. And that'll be much more accurate. So 1.282, 1.282, which is over there. And it gives me 1.282. Once I have this, I can solve them simultaneously. I've got two equations, equation number 1 over here, and I've got equation number 2 over here, and I can then solve it simultaneously. We can use the process of elimination, so using the elimination method, we can then solve to get sigma equals to 3.29, and the mean is equal to 7.78. Alright, and that's the answer for this question over here. Thank you. Finding sigma and the mean. Thank you.